For years, Pluto was treated as just a small, frozen speck lost on the fringes of the solar system, a distant, silent, and seemingly dead world, orbiting in darkness beyond the large planets. But everything changed when new observations began to reveal signs that this dwarf planet may be far more complex than we imagined. Now, scientists believe that one of the most unlikely places in the solar system may hide something extraordinary beneath its icy surface. Beneath Pluto's gigantic heart-shaped glacier, a vast, hidden ocean may exist. The discovery surprised researchers and raised a question that previously seemed impossible. Could this distant dwarf planet support some kind of life, or hide something even more mysterious beneath its frozen crust? The icy heart? If you've ever seen an image of Pluto, you've probably noticed its most famous feature, a huge heart-shaped region dominating one side of the dwarf planet. But this is no ordinary heart. It's an immense glacier called Sputnik Planitia, which has become one of the most intriguing places in the entire solar system. This colossal structure is so massive that it has literally altered Pluto's orientation in space. Imagine adding a gigantic weight to just one side of a ball. Over time, this weight would cause the ball to rotate until it found equilibrium. That's exactly what happened to Pluto. The glacier is so heavy that it ended up reorienting the dwarf planet, causing its heart to almost always face away from Charon, Pluto's largest moon. But what really impressed scientists wasn't just the size or shape of this region, but the fact that it's alive in geological terms. When researchers observed Sputnik Planitia more closely, they realized it's not a frozen, immobile landscape. On the contrary, it's constantly changing and moving. The surface is divided into enormous cell-like polygons that slowly rise in the center and sink at the edges. It's like a gigantic, slow-motion lava lamp made of nitrogen ice. And this is absolutely impressive because Pluto is extremely cold. We're talking about temperatures close to minus 232 degrees Celsius. Under these conditions, the nitrogen should be completely frozen and immobile. So why does this glacier keep moving? The answer may lie hidden just beneath it, and that's precisely what has scientists so excited. This isn't just an exotic formation on a distant world. It's a possible sign that Pluto hides surprising structures beneath its frozen surface, the subsurface ocean. This is where things get even more fascinating. Scientists now believe that beneath that enormous heart-shaped glacier lies something no one expected to find on a small, frozen dwarf planet, an ocean of liquid water. Not just isolated pockets or small underground lakes, but a gigantic ocean, possibly spread across much of Pluto's interior beneath its thick layer of ice. But how would that be possible? Pluto is almost 6 billion kilometers from the Sun. It is so distant that sunlight takes more than 5 hours to reach it. There simply isn't enough solar energy to maintain liquid water on its surface. Even so, all the evidence points to liquid water moving beneath the ice. And the explanation is fascinating. Inside Pluto's core, radioactive elements are slowly decaying. This natural process releases heat. Not much, but enough so that, combined with the incredible insulating properties of Pluto's thick ice layers, liquid water can exist. Sputnik Planitia's nitrogen ice acts like a huge blanket, trapping the weak heat coming from below. This ocean isn't simply stationary either. It likely influences everything that happens on Pluto's surface. Those polygonal patterns in the heart-shaped region? They're probably caused by convection cells in the ice, driven by the heat of the subsurface ocean. The cracks and fissures scattered across Pluto's surface? They may be the result of this ocean expanding and contracting as it freezes and thaws in different regions. The discovery of this hidden ocean changes everything we thought we knew about Pluto. It transforms our view of a static and lifeless world into that of a dynamic planet, with internal processes still active. And the most exciting thing of all is that whenever we find liquid water in the universe, a fascinating question immediately arises. Could life exist there? A geologically active world? When the first detailed photos of Pluto returned from NASA's New Horizons probe in 2015, geologists nearly fell out of their chairs. They expected to see an ancient surface, full of craters and unchanged for billions of years. Instead, they found mountains as high as the Rocky Mountains, vast craterless plains, and enormous cracks in the surface stretching for hundreds of kilometers. In other words, they saw a geologically alive world. That was truly impressive. For a long time, scientists believed Pluto to be just a frozen, inactive world, lost at the edge of the solar system. After all, maintaining geological activity requires energy, and Pluto exists in a region so cold that it resembles a true cosmic freezer. But the more researchers observed this dwarf planet, the more they realized that something extremely unusual was happening. The evidence began to accumulate rapidly. Pluto is not a still, dead world. Its surface is changing, evolving, and undergoing geological processes that no one expected to find so far from the Sun. Some regions of the surface are incredibly young in geological terms, possibly less than 10 million years old, something practically recent on the timescale of the solar system. Observations from the James Webb Space Telescope further reinforce this idea, revealing areas where ice appears to have flowed slowly across the surface, almost like thick honey oozing under extreme temperatures. Scientists also found enormous fault systems, regions where the crust cracked and shifted over time. And there are even more impressive signs, structures that appear to be cryovolcanoes, ice volcanoes capable of expelling mixtures of water, ammonia, and frozen compounds to the surface. One of the most intriguing discoveries is a gigantic network of cracks near Pluto's equator. These fissures suggest that the entire planet may have expanded at some point in its history. This could happen if a subsurface ocean began to freeze slowly. When water freezes, it expands. On a planetary scale, this process could literally force Pluto's crust to crack, like an eggshell subjected to excessive pressure. All this activity has forced scientists to completely change their view of small, frozen worlds. For decades, it was believed that bodies so far from the Sun quickly lost all their internal heat and became geologically dead. But Pluto seems to defy this logic. Even in the coldest and darkest places in the solar system, some worlds manage to preserve enough internal heat to keep geological processes active for billions of years. And this raises an even more fascinating question. If Pluto can hide so much activity beneath its frozen surface, how many other worlds considered dead might be secretly alive inside? And then we arrive at the most impressive possibility of all. Could Pluto actually harbor life? A few years ago, this idea would have been considered absurd. But the possible existence of a subsurface ocean has completely changed the scientific discussion. On Earth, every time we find liquid water, we find life. No matter how extreme the environment. Life exists in hydrothermal vents at the bottom of the oceans, in lakes trapped under kilometers of ice in Antarctica, and even in superheated hot springs that previously seemed impossible for any organism to survive. Water is an extraordinary solvent that allows the complex chemistry of life to occur. And now we believe that Pluto has water, lots of water. Of course, Pluto's ocean would be very different from those we are familiar with. It would likely be an extremely salty brine mixed with ammonia, which acts as an antifreeze to keep it liquid at extremely low temperatures. It would also be trapped under kilometers of ice, without any sunlight reaching it. Any life form there would need to survive in permanent darkness, extreme cold, and high pressure. But surprisingly, these conditions are not necessarily impossible for life. Here on Earth, we have discovered microorganisms that thrive without sunlight, obtaining energy through chemical reactions instead of photosynthesis. We have found organisms that survive in incredibly salty environments, and others that actually prefer extreme cold. The requirements for life appear to be far more flexible than we imagined. The James Webb Telescope has detected unusual thermal patterns and chemical anomalies on Pluto that are difficult to explain by normal geological processes. Some scientists have suggested that this could potentially be a sign of biological activity. Compounds associated with living organisms have been preliminarily identified, although we still need much more evidence before making any definitive claims. If life truly exists on Pluto, it would be unlike anything we have ever found before. It would have evolved in isolation for billions of years, adapting to conditions that seem impossibly hostile by Earth standards. These organisms could utilize biochemical processes completely different from those of terrestrial life, perhaps methane instead of water, or some form of chemistry we haven't even imagined yet. The discovery of life on Pluto, however simple it might be, would be revolutionary. It would suggest that life is not a rarity found only in the comfortable regions of solar systems, but something common that can arise even in the most extreme environments. This would mean that the universe may be teeming with life in places we never thought to look. A violent birth. How did Pluto end up developing such a complex and dynamic internal structure? The answer seems to lie in its violent birth, about 4.5 billion years ago. The most recent research suggests that Pluto did not form slowly and peacefully as we imagined. Instead, it was born amidst chaos and fire. When our solar system was young, it was a dangerous place, teeming with rocks and planetesimals colliding with each other. Scientists now believe that Pluto formed when a gigantic collision occurred, likely between two already considerable objects in what we now call the Kuiper Belt. This cosmic impact would have generated immense heat, instantly melting much of the material that would form Pluto. As this molten proto-Pluto cooled, heavier materials sank toward the center, creating a layered structure with a rocky core, a mantle of water ice, and a thin crust of frozen nitrogen and methane. This process, called differentiation, is crucial. This concentrated radioactive elements in Pluto's core, providing the heat source that kept parts of its interior warm for billions of years. Evidence of this violent birth can be seen in Pluto's relationship with its largest moon, Charon. Many scientists believe that Charon formed from debris ejected during the same gigantic impact that created Pluto. The two bodies are locked in a gravitational dance, always showing the same face to each other as they orbit around a point between them. Over billions of years, the heat from Pluto's core has slowly diminished as radioactive elements have decayed. But this process is incredibly slow, and the excellent insulating properties of the ice have preserved much of that original heat. Like a cup of coffee under a thick blanket, Pluto's internal heat was trapped, allowing its subsurface ocean to remain liquid long after we would expect it to freeze completely. This fiery beginning set the stage for everything that makes Pluto fascinating today. It gave the dwarf planet the energy and structure needed to develop complex geology, a possible subsurface ocean, and perhaps even habitable environments, all stemming from a catastrophic collision early in the solar system. Sometimes it seems that violence and destruction can lead to the most interesting results. The colorful sky of Pluto. Let's talk about something you might not expect from a world so far from the Sun. Even so far from the Sun, Pluto is not just a frozen rock lost in darkness. It possesses its own atmosphere, and it is one of the strangest and most beautiful ever found in the solar system. Of course, we're not talking about a thick atmosphere like Earth's. Pluto's gaseous layer is extremely thin, almost like a delicate mist slowly enveloping the dwarf planet. Still, what it lacks in density, it makes up for in complexity. Pluto's atmosphere is mainly composed of nitrogen, the same gas that dominates Earth's air, as well as small amounts of methane and carbon monoxide. But unlike Earth's relatively stable atmosphere, Pluto's is constantly changing as the planet travels its extremely elongated orbit around the Sun. When Pluto gets a little closer to the Sun, some of the ice on its surface evaporates directly into the atmosphere, making it thicker. Then, as it moves away again to the colder regions of the solar system, these gases begin to freeze and fall back onto the ground like a gigantic cosmic frost. But perhaps the most impressive aspect of this atmosphere is its appearance. Observations revealed that it glows with a soft blue hue when illuminated by the Sun from behind, an effect caused by the way its particles scatter light. And it's not just a uniform layer. Pluto's atmosphere is organized into dozens of nebulous layers stacked on top of each other, creating a delicate structure resembling a translucent blue onion enveloping the dwarf planet. But the most surprising part happens in the highest regions of this frozen haze. Even receiving a minimal amount of sunlight, Pluto harbors incredibly complex chemical reactions in its upper atmosphere. Ultraviolet radiation breaks down methane and nitrogen molecules, allowing them to recombine into more sophisticated organic compounds known as tholins. It is precisely these molecules that give Pluto its characteristic reddish color. Gradually, they descend from the atmosphere and accumulate on the surface, painting the planet with brown and golden tones seen in images captured by telescopes. Tholins are of enormous scientific interest because they are considered precursors to complex organic molecules, the same types of chemical compounds that may have participated in the processes that gave rise to life on Earth. They are not life forms, but they represent fundamental chemical building blocks that, under the right conditions, could contribute to the emergence of biological processes. Most impressively, all this happens in one of the coldest and darkest environments in the solar system. This suggests that the universe may have a much greater capacity to produce complex chemistry than we imagined, even in seemingly hostile and frozen places. And Pluto is not alone on this journey through the outer regions of the solar system. Beside it is Charon, its gigantic cosmic companion. But the relationship between the two is so unusual that it challenges the traditional way we think about planets and moons. Charon is not just an ordinary moon orbiting Pluto. The two bodies are locked in a kind of unique gravitational dance. While most moons are much smaller than the planets they orbit, Charon is almost half the size of Pluto. This makes the system function more like two worlds orbiting together than like a simple planet accompanied by a moon. In practice, Pluto and Charon revolve around an invisible point located between them, called the barycenter, creating one of the most fascinating pairs in the entire solar system. For comparison, while our moon orbits the Earth-Moon barycenter is still inside the Earth. But the Pluto-Charon barycenter lies in the empty space between the two. Even stranger, Pluto and Charon are gravitationally locked to each other. This means that they always present the same face to each other while orbiting. If you were on the side of Pluto facing Charon, you would see Charon fixed in exactly the same point in the sky, never rising or setting. On the opposite side of Pluto, you would never see Charon. Charon itself is a fascinating world. Unlike Pluto's colorful surface, Charon is mostly gray, with a distinct reddish region in the north that scientists have nicknamed Mordor. This red material is believed to be formed from tholins captured from Pluto's atmosphere. When methane gas escapes from Pluto, some of it is trapped by Charon's gravity and freezes at its cold pole, where ultraviolet light transforms it into these complex red compounds. The James Webb Telescope has revealed detailed images of Charon's surface, showing enormous canyons that make the Grand Canyon look like a small crack in comparison. One canyon system stretches for more than 1,600 kilometers and is 4 times deeper than its Arizona counterpart. These gigantic structures suggest that Charon was also geologically active, possibly because its interior expanded when groundwater froze and cracked the surface. The relationship between Pluto and Charon has profound effects on both worlds. Their gravitational interaction creates tidal forces that generate heat in their interiors. This extra heat source may help keep Pluto's subsurface ocean liquid and may have driven geological activity on both worlds. Their dance through space is not just a celestial curiosity, but potentially a life-favoring relationship that has shaped the evolution of both worlds for billions of years. The strange world of the Kuiper Belt. Pluto is not alone in the distant regions of our solar system. In fact, it is part of a vast population of icy objects called the Kuiper Belt, a kind of cosmic junkyard remaining from the formation of the solar system. This region extends from just beyond the orbit of Neptune to about 50 times the distance from Earth to the Sun and contains countless objects, from small icy fragments to dwarf planets like Pluto. What makes the Kuiper Belt fascinating is its role as a time capsule. While the inner solar system has been dramatically transformed by the Sun's heat and the gravitational interactions of the planets over billions of years, many objects in the Kuiper Belt have remained virtually unchanged since their formation. They are like frozen fossils of the solar system's birth, preserving information about the conditions that existed when Earth and the other planets were forming. Pluto is the largest known member of the Kuiper Belt, although distant Eris is very close in size, but it is far from being the only interesting object there. We have discovered other dwarf planets, such as Haumea, which rotates so rapidly that it has become elongated like an egg, Makemake, which appears to have a methane-rich surface similar to Pluto's, and Quaoar, which may also exhibit cryovolcanic activity. There are probably dozens of other dwarf planets waiting to be discovered. What intrigues scientists is why Pluto appears much more active and complex than other similarly sized objects in the Kuiper Belt. It seems to have struck an ideal combination in terms of composition, internal heating, and geological history that has allowed it to develop features not seen elsewhere. Understanding why Pluto is special could help us better understand how planets form and evolve throughout the universe. The Kuiper Belt is not only scientifically valuable, but it is also becoming increasingly important for future space exploration. These objects contain enormous quantities of water ice, organic compounds, and other resources that could be crucial for human expansion into the outer solar system. Some scientists envision a future where Kuiper Belt objects serve as landing points and refueling stations for missions that venture even deeper into interstellar space. The discoveries we are making about Pluto may be just the beginning of a whole new understanding of this mysterious region. Each object in the Kuiper Belt likely has its own unique story to tell, and together they could revolutionize our understanding of how solar systems form and evolve throughout the universe. Beyond New Horizons. In 2015, NASA's New Horizons probe gave humanity its first close-up view of Pluto as it flew past it at over 48,000 kilometers per hour. These images transformed Pluto from a blurry dot in our telescopes into a complex world, with mountains, glaciers, and a distinctive heart-shaped formation. It was a revolutionary moment in the exploration of our solar system. But New Horizons' visit was brief, a flyby that lasted only a few hours and left us with many new questions. Since then, the James Webb Telescope has provided us with incredible data, but even its powerful instruments can only observe a fraction of what exists billions of kilometers away. To truly understand the mysteries of Pluto, we need to return, not just for another quick visit, but for a prolonged investigation. Scientists are now envisioning the next generation of missions to this fascinating world. One of the concepts under consideration is a Pluto orbiter, a spacecraft that would enter orbit around the dwarf planet instead of simply passing by it. This would allow for months or even years of detailed observations, mapping the entire surface in high resolution and observing how it changes with Plutonian seasons. Advanced instruments could analyze its atmosphere, measure its magnetic field, and investigate its internal structure to confirm the existence of that subsurface ocean. Even more ambitious would be a Pluto lander capable of touching its icy surface. Imagine a robotic explorer collecting samples of the reddish tholins, measuring the properties of the nitrogen ice, and perhaps even detecting signs of internal heat or seismic activity. Such a mission could revolutionize our understanding of the chemistry and geology of objects in the outer solar system. The most exciting, albeit technologically challenging mission would be one capable of detecting and studying Pluto's supposed subsurface ocean. Perhaps a specially designed probe could use radar to see beneath the ice, or a highly sensitive instrument could detect chemical signatures emanating from the depths. If we could confirm the presence of liquid water and analyze its composition, we would obtain extraordinary information about Pluto's internal processes and its potential for habitability. These missions face enormous challenges. The immense distance to Pluto means communication delays of more than 5 hours in each direction. The extreme cold and low light levels make power generation difficult, and the journey itself would take years, even using our fastest spacecraft. But the potential scientific return is equally enormous. As our technology advances, especially in areas like nuclear propulsion, artificial intelligence, and low-temperature electronics, these ambitious missions are becoming increasingly feasible. The future of Pluto exploration may be closer than we imagine. The mysteries of this fascinating world are calling to us from the edge of the solar system, waiting to be revealed. The invisible shield. There is another Plutonian mystery that has received far less attention, but which may be crucial to understanding this world: the possibility of Pluto possessing a magnetic field. Although we haven't directly confirmed this yet, several lines of evidence suggest that it may exist, silently influencing everything from Pluto's atmosphere to its habitability potential. Magnetic fields are created when electrically conductive materials move within a planet. On Earth, our magnetic field comes from liquid iron swirling in our outer core. But Pluto is too small to have maintained a molten metallic core for billions of years. If it does possess a magnetic field, it likely comes from a different source. We talk so much about if Pluto's hidden ocean contains dissolved salts, as many scientists suspect, it would be electrically conductive. As Pluto rotates and this salt water moves, it could potentially generate a weak magnetic field. The New Horizons probe wasn't equipped with a magnetometer sensitive enough to detect this type of field during its brief flyby. But some anomalies in its data suggest that something interesting might be happening. Why does this matter? A magnetic field acts like a protective bubble around a planet. On Earth, our magnetic field protects us from harmful solar radiation and helps prevent our atmosphere from being stripped away by the solar wind. Although Pluto is much farther from the Sun, it is still exposed to cosmic radiation and the thin but persistent solar wind that permeates the entire solar system. If Pluto does indeed possess a magnetic field, even a weak one, this could help explain how the dwarf planet has managed to retain its thin atmosphere for billions of years. This could also create a more protected environment for its subsurface ocean, potentially making it more habitable for any hypothetical life forms. The James Webb Telescope has observed unusual patterns in Pluto's atmosphere that some scientists believe may be influenced by a weak magnetic field. Certain structures appear aligned in ways that could indicate the presence of magnetic forces shaping the movement of charged particles in the upper atmosphere. Confirming the existence of a magnetic field on Pluto will require a new space mission equipped with specialized instruments. But if it really exists, it would be further strong evidence that the dwarf planet hides an active subsurface ocean, and perhaps favorable conditions for simple forms of life. Even in the frozen limits of the solar system, Pluto is far from being an isolated and immobile world. Its enormous moon, Charon, exerts intense gravitational forces that generate internal heat through tidal effects, possibly helping to maintain liquid water beneath the frozen surface. In addition to Charon, Pluto has other small moons and is constantly influenced by the gravitational influence of the Kuiper Belt, the vast region full of icy objects where it orbits. Over billions of years, these interactions and collisions have shaped its structure, its orbit, and perhaps even the formation of Sputnik Planitia, the famous heart-shaped region. All this has revealed something surprising. Pluto is not just a distant ball of ice. It is a dynamic, geologically active world, far more complex than we imagined. A place that can help scientists understand not only our solar system, but billions of similar worlds scattered throughout the galaxy. Thanks for watching. If you enjoyed it, don't forget to like and comment what you thought. See you next time.